Hello everyone, you are highly welcome to this class. This is mathematics class, and today we are here again to look at this important topic, integration, and in particular we'll be considering integration by parts. So I'll be studying integration by parts. So I have a formula I have written down here that integral of u dv is equal to uv minus integral of v du. This is formula you use for performing integration by parts. Both u and the v are functions. So u is a function, the v is also what? A function. So these two things are products of two functions. So let's know how to apply this formula using this example we have on the board here. Ask us to evaluate integral of x cos x with respect to x. So we have products of two functions, x cos x, right? So which one will be u, which one will be the v? That's the question now. So the one that you are going to call u is the one that will vanish if you differentiate it a certain number of times. We know that if you differentiate cosine x many times, you will be getting cosine sine, so it cannot vanish. But if you differentiate x will automatically vanish at a certain number of times, right? If you differentiate x, you are going to get what? 1. And if you differentiate again, you get 0, so it will vanish, right? So the one that will vanish is the one that you are going to call what? U. And the one that will not vanish is the one you are going to call what? The v. So I'm going to say let u be equal to x and the v be equal to what? Cos x, right? So this implies, so if u is x, and in the formula we are having the u, look at this formula, we have the u here. So all these things we need to get them. We have u already to be x, right? Then with v, we need to get v. We know that the v is what? Cos x. We called the v cos x. So we need to get what? V. So from this one, I can get the u from this writing. Since u is equal to x, so I can differentiate this u with respect to x. So if you differentiate u with respect to x, if you differentiate x, you get what? 1. So this implies if I make du the subject of the formula, then du will be equal to the x multiplied by 1, which is what? The x. Right? So du is the same thing as what? The x. Also, we also have that dv equals what? Cos x implies, so we have that dv is what? Cos x. This implies that integral of dv is equals to integral of cos x with respect to x. So this thing I wrote down here is, I have dv is cos x. So if I integrate both sides, integrate this side, so integral will cancel the derivative. What will now left is what? V. V will be what is left. Then integrating cosine, we know that integral of cosine is positive sign. So this will give you positive sine x. So I've gotten v. We call x u, and we have gotten du to be equal to the x. So we can go straight and use this formula we have here. Integral of x cos x with respect to x will be equal, the formula is uv. So what is our u? X multiplying, what is our v? Our v, we calculated it to be what? Sine x. So we have x sine x. Then we have what? Minus. Then integral of v. What is our v? Sine x. Sine x. Then du. We calculated du to be equals to what? The x. Dx. So we now simplify. This is x sine x then minus, we have minus here, then integral of sine. Integral of sine is negative cosine. So you are going to have negative cosine. But we have negative here. Negative, negative will be positive. So we are going to have positive cosine of x. Then plus constant of integration c. So this gives us the result of the integral of the product of these two functions. So I'm expecting you in our upcoming class as we solve more examples.